Okay, ladies and gentlemen, we're going to start off with rational inequalities. So the first thing we need to discuss is something called a critical point. Okay, a critical point will do one of two things. It makes the function equal 0. Okay, now in the instance of a rational inequality, the function equals 0 where the numerator equals 0. Okay, the second place where a critical point might occur is a value of x that makes the function undefined. In the instance of a rational inequality, this will occur where the denominator is equal to 0. Okay, so there are a couple different steps into solving these. It's not like solving just like kind of like a normal inequality. So your very first step should be to find those critical points. Okay, so let's start off with a very kind of simple one, and I'll just walk you through it. Okay, again, we're going to do a couple of videos. We'll start up simple and then we'll go more complicated. Okay, so first we're going to look for our critical points. So the first one I want to deal with is the one that makes the numerator 0. So what I do Okay, now notice that your inequality is equal to 0 in itself, so that kind of shortens the process. So first we're going to set the numerator equal to 0. So that'll give us so x equals 2 is a critical point. Okay. Second, we're going to figure out where the denominator equals 0. So x equals 8 is a critical point. Now, it also is a point that you cannot have. So 8 will get an open dot when we graph these on the number line. Okay, because x cannot never equal 8 because that would result in division by 0, which is undefined. So it doesn't matter. Oops. It doesn't matter that the inequality itself says equal to in this instance. So if your denominator is equal to 0, x cannot equal it in any sense. Okay, so now since we have all of our critical points, okay, what's going to happen is we're going to graph those on a number line. And then we're going to use test values. Okay, so negative infinity is on your left, positive infinity is on your right. 2 is here, 8 is here. Okay, 8, as we said, gets an open dot. Now 2 will get a closed dot because that's what your inequality states. Now, when you pick your test intervals, please remember that you are open to choosing any number within that test interval you want. So you can choose any number between negative infinity and 0, or excuse me, and 2. So you could choose 0. Okay, that's a perfectly valid test point. Okay, any number between 2 and 8, 5 seems good. And any number between 8 and positive infinity, I like 10. Okay, what you're doing is you're looking for a true statement. So you want to make sure whatever value you plug in for x is going to be less than or equal to 0 to get a true statement. Okay, let's plug in our 0. Okay, so I get a negative 2 divided by a negative 8, which is a positive value that is not less than 0, so that is false. Okay, so let's plug in our 5. Okay, 5 minus 2 is 3. 5 minus 8 is negative 3. That is a negative 1, which is less than or equal to 0, so that is true. Okay, let's do the last test value. Let's do a 10. Okay, so I have 8 divided by 2, which is 4, which is not less than or equal to 0, so that would be false. Okay, so we want to shade truth. So our solution set is between 2 and 8. So our answer is just like that. Okay? All right. So that one wasn't too bad. Let's try another one. Let's try a little bit tougher. All right. So you'll notice that we have a quadratic on the top. We still need to find our critical points. We still need to figure out what makes that numerator 0. So let's see, x squared minus x minus 42 is equal to 0. Notice in the beginning you're kind of almost ignoring the inequality. All right, I need to think of two numbers that multiply to a negative 42, but combine to a negative 1. So that would be negative 7 and positive 6. So that would give me critical points at x minus 7 equals 0, x plus 6 equals 0, or x equals 7 and x equals negative 6. All right, so the next type of critical point gives us the denominator is equal to 0. Remember, these values are not allowed at all, so they will always give you an open dot. So we're going to have another critical point at x equals 1. Notice that this one will always get an open dot because it is excluded from the x values because you cannot divide by 0. Okay, here we go. We're going to use our number line and some test points. Now notice if I have 3 test points, I actually cut up my number line into 4 different intervals. Now please make sure you put your numbers in the right order. Like that. All right, I'm going to write my inequality at the side. So I can remember what it is. Okay, so let's see. I need to choose a value between negative infinity and negative 6. So let's go negative 10. And you can choose any number you want. So if you want to choose negative 7, choose negative 7. All right. I need to choose a number that is between negative 6 and 1. That would be 0, would be good. I need to choose a number between 1 and 7. I like the number 5. But you can choose 2, you can choose 3, just as long as it's between 1 and 7. And then for our last interval, we need a number between 7 and positive infinity, and I'm going to choose positive 10. Okay, so again, you just need to decide if it's true or false. Okay, let's do a little scratch work. Let's see, negative 10 squared, and you're plugging these test values in for x. So negative 10 squared is 100, minus 10, minus 42, and then negative 10 minus 1. Now, since it's less than or equal to 0, you might just have to look at the signs. Okay, so you have to just decide if it's positive or negative. So I have a positive value on the top and a negative value on the bottom, which gives me a negative, and negatives are always less than 0, so this is true. Okay, if I plug in a 0, I get a negative divided by a negative, which is a positive. Positive numbers are not less than or equal to 0, so this is false. Okay, let's plug in a 5. So 25 minus 5 minus 42 over 5 minus 1. So that's a negative divided by a positive, which is a negative. Negatives are always less than 0, so true. Let's plug in our 10. Now remember, this is a positive 10, not a negative 10, so it's going to look a little bit different. So I get a positive divided by a positive, which is a positive. Positive numbers are not less than 0, so this is false. Okay, remember, you got to shade where truth is. So, true false, true, false. Now remember, the 1 always gets the open dot because it's the value that makes the denominator equal to 0, and we can't have that. So our solution would be that. Okay, we'll do a couple more in a few minutes, but yeah, that's rational inequalities. I hope that helps you out. We'll also do a word problem later on. Okay.